So, let me summarize what we did today. Really, what we came down to is there's three types of functions that we're looking at. Linear, quadratic, and exponential. And they're all different. They look different. This is a straight line, this is the parabola, and this is the J-shaped exponential growth. They all three have different equations. If it's linear, y equals mx plus b, we know that. Quadratic, ax squared plus bx plus c. Exponential is y equals a, b to the x. So we've talked about that. So then, how do we know which one is which? So I took the problems off the homework, and I started with first this time and amount in monies. And what I'm looking for is differences. When we talk about differences, we say, okay, what's the difference between 20 and 22, 22 and 24, 24 and 26, 26 and 28? So we notice that it goes up by 2, up by 2, up by 2, up by 2. So the first difference is all the same. First difference is all the same. So we know if it's the first difference, we know it has to be degree 1. It has to be degree 1, which makes it linear, because this is an x to the 1 power. So if we know it's linear, then we can go straight to y equals mx plus b. Let's start there. The m is going to be the slope. The m is going to be whatever the first difference is, which is 2. So the m is going to be what the first difference is, which is 2. So I'm going to take my 2 and put it in for m. All right, so instead of y equals mx plus b, I've got y equals 2x plus b. The 2 comes from the difference. Now, I need to know the b. So to find the b, I just pick any of these points. The easiest point to pick is the 1 and 20. And so I simply put my 20 in for y, my 1 in for x, and I solve b. 2 times 1 is 2, minus 2, b is 18. So I would have a y equals a 2x plus 18. However, these are all in terms of formulas like n. So instead of y equals 2x plus 18, I need a formula. So y, instead of y, it's just 2n plus 18, which creates each of these terms in my sequence. Okay, that wasn't too bad. Let me turn the page. So then we also talked about if it's going to possibly be quadratic. So I took the example of the grapes, and I wrote the grape bunches down in a chart. So one grape has 6, 2 bunches has 14, 3 bunches has 24, and 4 bunches has 38. And now, again, I'm looking for my differences. So 6 to 14 is 8 more. 14 to 24 is 10 more. 24 to 36 is 12 more. First difference is not the same. It's not the same, so is not linear. First difference is not the same, so it's not linear. So then I do it again. Now I'm looking for the second difference. So I'm looking at subtracting these numbers. Subtract your first difference numbers. So 8 from 10 is 2. 10 from 12 is 2. So the difference is 2. Now, since these are the same, then I know that it's the second difference. The second difference comes from degree 2, which is some x squared equation. Well, a quadratic comes in the form of y equals ax squared plus bx plus c. Well, how do I get this? A is not too bad. A is going to be whatever the second difference is divided by 2, always, okay? Whatever the second difference is, which in this case is 2, divided by 2. So, second difference is 2. 2 divided by 2 is 1. So, A is 1. So, I'm going to put a 1 right here. So, y equals ax plus bx, ax squared plus bx plus c. A is 1, so put a 1 here. I still don't know b, and I don't know c. C has got to be the y-intercept. I mean, if I were to take and look at a sketch of any graph, no matter where the parabola goes, C has an x value of 0, okay? Well, go back to my chart. I've got an x value of 1, 2, 3, 4, and I put 0 in. So I'm working backwards. 4, 3, 2, 1, 0. And I'm going to work backwards on this one. Here's where it's tricky. I'm going to go slowly. I'm working backwards. So 36 take away 12 is 24. 24 take away 10 is 14. 14 take away 8 is 6. So 12, 10, 8, 6. So I need to take away 6 from 6, which tells me 0. So this is a point at 0, 0. If this is a point at 0, 0, then C must be 0. C must be 0 because that would be the y-intercept. So now I know C is 0. So if C is equal to 0, then I can go back to my ax squared plus bx plus c. I'll put 1 in for A, and I'll put 0 in for C. So if I rewrite that, I put 1 in for A and 0 for C. Now, I'm down to just finding B. So that's not so bad. If I only have to find one thing, I'm going to pick a point up here. Let's pick the easiest. Don't pick 0, 0. Won't work. Pick 1, 6. So that's a y value. Pick a point. That's a y value. That's an x value. So I took my 6 and put it there. And I put my 1, which is an x value, and put it in for my x's. So 6 is equal to 1 times 1 squared plus b times 1 plus 0. So I plugged my 6 in for y and my 1's in for x's. Then I simplified. Well, 1 squared times 1 is 1 plus 1b. So then I can solve for b, minus 1, subtract 1, like minus 1 gives me 5. So b is 5. So here's what I know. A is 1. C is 0. B is 5. So my equation is y equals a 1x squared plus 5x plus 0. But it's really, we're talking about n's because we want to create a sequence. So instead of 1x squared, it's 1n squared plus 5n, and I don't need the 0. Okay? Finally, the third one is exponential. Okay, so then if we go to our exponential, and this was the problem on the cars, okay? Is it cars? Yeah, cars. So first photo is 2 cars, second photo is 4 cars, third photo is 8 cars, fourth photo. Now, if you take a look at the differences, they don't make any sense, but what I do see is not differences, but times. If I go 2 times 4 is 2. 4 times 2 is 8. 8 times 2 is 16. So it's not a difference. No, it is not a difference. So it won't be any kind of polynomial, but it will be exponential because it is multiplying by 2. So here's our formula for exponential. Y equals ax, a times b to the x. And so I know I'm multiplying by 2, so my rate or my base is 2. My beginning is 1, and I know it's to the x power. And that's how I got my answer. Okay, so again, we might look at this again tomorrow. We'll check it out. Okay, so that's what I have. If you guys want to watch the film, you can. Pause it, rewind it, whatever. Have a great night.